Not present here. I'm Ramya Devi, working as assistant professor in SNS College of Engineering. Today I'm going to share a small article regarding the subject called data science and analytics, in which predictive modeling and machine learning, in which how we are going to detect the outliers. So basically, what is an outlier? So whenever a data is considered beyond the range, that is, for example, if we are taking the data as age means, so the age can be between 0 to 99, but if the age is like 105 or if the age is goes in negative, so that data will be wrong. So that type of data can be considered as outliers, and that should be detected before pre-processing the data. So the outliers of the data will be considered in the pre-processing stage, in which we have to correct all the data and send for the processing or analysis. So outliers are those data points that are really far from the rest of your data points. In other words, an outlier is the value or data point that differs substantially from the rest of the data. So reasons why do these outliers of data happens? So errors during data entry. So if and like for example, as I have told, like if age is the value, if is the field of the data set, and if we are trying, if it is wrongly entered the age in a negative number, or if it is wrongly entered the age as like 200 or 120 or 125, which cannot be a range of your age data means, so that faulty data will be considered as the outlier data. So that should be detected in the data cleaning process or the data pre-processing, and that should be totally eliminated, and then after that only we have to load the data for analysis. So like what are the reasons behind the outliers means, so the main reason is errors during data entry, or a faulty measuring device. A faulty sensor may result in extreme reading. So the extreme range of the data, and naturally also the data error can also occur. And next is the box plots. So the box plots are a visual method to identify the outliers in a data. So box plots is one of the many ways to visualize the data distribution. So box plots means we have to, so if the data is distributed evenly, so that we have to first calculate the percentile or the median of our data, so that we can find out the 25th percentile or 50th percentile, or it is also called as median, or 75th percentile of the data. Okay, so if we find out that, so we can identify the median of the data. So too much range, if the data has gone beyond this range, can be considered as outliers, and we can totally eliminate the data. For example, first we have to calculate the Q1, which is 25th percentile, and Q2, which is 50th percentile, or it is also called as median, and Q3, it is 75th percentile of the data along with. So how we will calculate? So we have to Q1, the 25th percentile, minus 1.5 into Q3 minus Q1. So Q3 is the 75th percentile, and we have to make the difference of 75th percentile to 25th percentile, so which we will get the 50th percentile. And also Q3 plus 1.5 into Q3 minus Q1. So outliers, if any, are plotted as points above and in the below plot. See, and the next method is the IQR method, that is the interquartile range. So the IQR method is used by box plot to highlight the outliers. So IQR stands for interquartile range, so which is the difference between the 75th percentile and 25th percentile. So that is the median of the data distribution. So the IQR method computes the lower bound and upper bound to identify the outliers. So the lower bound can be calculated as Q1 minus 1.5 into IQR, and the upper bound is calculated as Q3 plus 1.5 into IQR. So the IQR is interquartile range, which is a difference between 75th percentile and 25th percentile. And this is the interquartile range. Here the minimum is Q1, which is 25th percentile, and the maximum is Q3, which is 75th percentile, and the interquartile range or IQR or medium is calculated the difference between your 75th percentile and 25th percentile. And also we can use the z-score method. So z-score method is another method for detecting outliers. So this method is generally used when a variable distribution looks close to Gaussian. So the z-score is the number of standard deviations. A value of a variable is always from a variable mean z-score, like x mean divided by the standard deviation. When the values of a variable are converted to z-scores, then the distribution of the variable is called standard normal distribution, with mean is equal to 100 and standard deviation is equal to 1. So the z-score method requires a cutoff specified by the user to identify outliers. The widely used lower end cutoff is -3 and the upper end cutoff is +3. And this is the outliers, which is moderately unusual. So these that like the -3 and +3 is considered as an outlier, and that data will be eliminated. And also the multivariate method. Here, unlike the previous method, this method considers multiple variables in a data set to detect outliers. This method calculates the equilibrium distance of the data points from the mean and converts the distances into absolute z-score. So any z-score than the pre-specified cutoff is considered to be an outlier. Thank you.